This is my Lab 1 for Physics 2212 by Elias Germoman. The main introduction for this lab is that ordinary objects can be charged if they gain an excess of negative electrons or a deficiency of negative charge, which would result in a positive charge. This can happen by rubbing, pulling, or even touching two objects. The amount of excess charge can range from 1 electron to all the electrons in an object, and this is a wide range, so there are certain ways to test this. And in this lab, we will explore by using the force of gravity and the electric force exerted by two pieces of tape that float on top of one another. The main physics principles that will be used in this lab are Coulomb's law and Newton's law, and they will represent gravity and electric forces. So a charge tape is created by placing a piece of tape on a desk and putting a tape on top and moving it quickly, resulting in the charge tape. The length of this tape is 20 centimeters and the mass of the tape is 0.0002 kilograms. The first part of the results were deduced by placing a charge tape against the desk, and charged tapes would repel each other, meaning that they have the same charge. The tape was attracted to the neutral hand, and when running a pen through hair and creating a negatively charged pen, it was strongly attracted to it, which means the tape strips are positively charged and they have a deficiency in electrons. So main question was, if electrons are and protons are their charges are reversed, what would happen? And nothing would change because like would still repel like and opposites would still attract, and the interactions in the last slide would still exist. So the second part of the experiment was placing a charged tape suspended in air and another charged tape under it and seeing what would happen. What happened was the charged tape on top would begin to float. And the average floating distance or distance between them would be about 0.03 meters. And this means that the gravitational force that was pulling the top tape down was canceled out by the electric force from the bottom tape. And that means that the net force is zero. So the gravitational force can be calculated by mass times the acceleration of gravity, and this resulted in a gravitational force of 1.962 times 10 to the negative third newtons. That means that the electric force was also equivalent to that, and using Coulomb's law, the charge of one tape could be found by rearranging to find Q. The electric charge was calculated to be 1.4 times 10 to the negative 8 coulombs, and an assumption was made that each tape was just a point charge. So the number of electrons was calculated by using the total charge and dividing it by the charge of one electron, and this was resulted in 8.75 times 10 to the 10th electrons missing because it was a positively charged piece of tape. The number of atoms was calculated by finding the area of an atom, the area of the tape, dividing the area of the tape by the area of the atom, and doing this found out that the number of atoms was 4 times 10 to the negative 4 times 10 to the 17th atoms. The ratio of the electrons to the atoms was 1 electron for every 4.57 times 10 to the 8th atoms, which means there were a lot more atoms and protons compared to the electrons that were missing. In the glow strip model, the first computational model depicted that each piece of tape was just a point charge and that the electric force was at the center and the gravitational force was also at the center, and that they equally repelled each other. And using that, the charge was found to be 1.4 times 10 to the negative 8 coulombs for each piece of tape. The second computational model distributed the charge across the piece of tape in 10 equivalent points. When looking at this, the charge was actually calculated to be 2.128 times 10 to the negative 8 coulombs because the charge was distributed, and the force of gravity was still located at the center. So it had a higher overall charge. The question was, why did this happen? Why is the line charge model higher than the point charge model? And if you look at it, the line charge model had a higher charge because it had to produce the same force required to counteract gravitational force and float, but it wasn't all at the center like the point charge model. This is because there was increasing distance from the center point of the top tape where the force of gravity is located, and the distance, such as the locations in the corners, and you can see this at the tape in the top model where the green is smaller in the middle. And so it was farther away, and in Coulomb's law, the farther away the charge is, the less force that is placed on the tape. So that means that there had to be more charge to create the same amount of electric force. The line charge model more accurately displays what would actually happen because the absence of electrons exists throughout the tip, not solely at a single point. And in the discussion, the coding gave a clear visual of how more charge would be needed if the charge is distributed evenly due to the increased distance from the center of force of gravity. The data makes sense because both pieces of tape are positive charged and they would repel. And a source of error that could have happened was that resulted from overly touching the tape, which would cause it to lose charge. Thank you so much for listening to my presentation.